All right, section 5.6. Number 20 says solve this. So we have subtraction of logs, and we got just a number over here. Now if it was logs equal a log, if we could get it to a single log equal a single log, the arguments would have to equal. But if it's here, we're probably going to change it back to a power equation. Now first of all, we just have to have it down to a single log equation, so that would, if we're subtracting, that would be the log, and this is base 10 because there's no base written, of 2x divided by x minus 3 equals 1. Now the rule says that if you have b to the a equals c, that can be written as a log of to what power do we take b to get c, and that is the power of a. So we've got the log, and we're going to go back to a power. So the base is 10. So we have 10 to the a, which is the 1. So we have 10 to the 1 equals c, this thing in here, 2x over x minus 3. 10 to the 1 is 10, so I multiply both sides by x minus 3. And I get 10x minus 30 equals 2x. Subtract 10x and I get negative 30 equals negative 8x. Divide by negative 8 and I get x equals 30 and a half, 15, 7 and a half. Now let's check our answer. So I'm going to turn my calculator on and put 7.5 and store that in x so that I can just type log 2x close parenthesis minus log parenthesis, or already has it, parenthesis, x minus 3 close parenthesis, and it's supposed to come out to be 1, and it didn't. So I've got something wrong here. What did I do wrong? This divided by this. Okay, so I multiply by x minus 3, so that's, yeah, 10 to the 1 is this. So that's 10x minus 30 equals 10 to the 1 is 2x over x minus 30, so that's 10x minus 30, and this is 2x. If I subtract 10x from both sides, I get negative 8x. If I divide by 8, let's make sure I divide that right. 30 divided by 8. Oh, 3.75. I didn't divide correctly. I was doing that in my head and got the wrong answer. So let's store that into x and then retype that. And that would be this, and now it does come out to equal 1. So there you see the advantages of checking. I did a silly mistake here. The answer is 30 over 8, and I did 30 over 4 last time. Messed that up. Okay, number 30. Same kind of thing. We got logs over here and a number over here, so we're going to get this to a single log. So we're going to say this is log base 4 of, this will go in the numerator because this is the positive one. So I get x squared minus 9 divided by x plus 3 equals 3. So now using the change from a log to a power, I get this 4 to the third equals x squared minus 9 over x plus 3. Now this is 64. on the left side. On the right side, I can multiply by x plus 3 on both sides, but x squared minus 9 factors to x plus 3 and x minus 3, and so the x plus 3's will actually cancel, and so if I add 3 I get 67 is equal to x. And the one thing I got to watch out for is x could be negative 3 here. Negative 3 would make this be 0, so that can't be used. So looks like 67 is the answer. Let's check it out. So 67 store in x, and then I'm going to type in, now to type in log base 4, you can go log of x squared minus 9 all divided by log of 4. That's the change in base rule. That's how I would type this in. Minus log base 10 of x plus 3 divided by log of 4, and that's the change of base rule there, and that's supposed to come out to be 3, and did that one right. Now 55. This one, now you could take there's a couple ways to go here. We can take the log of both sides, and we can do a log base e since this has a base of e. So we'd have ln of pi to the 1 minus x equals ln of e to the x. The x could come down, the 1 minus x could come down, and so I'll have 1 minus x times ln of pi equals x ln e. Now, to what power did I take e to get e? That's 1. So this is 1. They cancel each other out. They're basically inverse operations. So over here I've got pi times ln pi times 1, which is ln pi, minus ln pi times the negative x is negative x ln pi equals x. So I can add this x term to the other side, and I'd have ln pi equals x plus x ln pi. And if I factor x out of these, I get x times 1 plus ln pi. And so I divide both sides by 1 plus ln pi. And that's what x is, ln pi over 1 plus ln pi. Now, the other way to do this one would be to change these into the same base, like maybe base 10 or base e. Since you guys like base 10, I'll do 10. So this would be 10 to the log of pi, that's another name for pi, to the 1 minus x equals, and this would be 10 to the log of e, that's another name for e, to the x. They have the same bases, so the powers must be the same, and we have power to power, so we've got to multiply, so we get log of pi times 1 minus log of pi times x, and over here I get x log of e. So I need to get the logs on the same side, and so I'll add this to this side, so I'll have log of pi equals x log e plus x log pi. I'll factor out the x, and then divide by this expression, log e plus log pi. And that's what x will equal. Now, you can do the arithmetic on this, and you should get the same answer. Let's see, last time, did we even do it here? And I should check my answer. So let's do ln pi divided by parenthesis 1 plus ln pi, and I get that number. I'll store that in x, and now I'll write this equation in. Pi to the 1 minus x. I get this number, and now I'm going to take e to the x, and I get the same number, so the two sides would be equal with that. Now the only thing I have to do is, this is what I got for this answer. Now I need to check that and see if this one is the same answer. So that's log pi divided by parenthesis log e plus log pi, and it's exactly the same number. So either one of these is a correct answer, and if I'd gone to base e on this, I would have gotten exactly that same answer, but I used base 10, and so I got something that looked a little different, but it is the same number. Okay, now 60. Okay, there's several problems in this area, and the 60 wasn't one that was assigned, but I want you to kind of get an idea in this section around 60, 50s through 60s. These are quadratics that don't look like quadratics at first glance. But if you think of this as 2 to the x to the 2, because that you can write this as this, because you'd multiply the powers and you get that. And if you think of this, now when you got add the exponents, that comes from a multiplying. So this would be 2 to the x times 2 to the 2, because you add the powers when you multiply. So if this were my variable, I have the variable squared plus 4 times the variable minus 12. This looks like a variable squared plus 4 times the variable minus 12 equals 0. And this can be done in the quadratic form, and you might be able to even do it with factoring here. Let's see if I can. This would be z plus 6 and z minus 2. That would make minus 12, and minus 2z plus 6z is plus 4z. So that's how it factors. So z would have to be negative 6, or z would have to be 2. Now z, I just was using that as a placeholder for 2 to the x. So what I really have is 2 to some power equaling a negative 6. Well, 2 to no, there isn't any power I can take 2 to get negative 6, so there's no answers out of this. But 2 to the x equaling 2, x would have to equal 1. And that's the solution to this problem. Okay, that's it for 5, 6.